Number 87, Billy was traveling on a number line with velocity function blah blah blah. At time 0, he was 10 units left of 0. What is Billy's position at t equals 1? Well, what I would do is I would compute the displacement from time 0 to time 1, and that would be given by the integral of v of t from 0 to 1. So that right there, that's going to be the displacement from 0 to 1. That's going to tell you how far Billy moved left or right over that time. And of course, we know that he started at 10. So 10 plus this guy will tell you where Billy is at t equals 1. You can kind of think of this as like a later value equals earlier value plus the net change problem. You can think of it as one of those. Anyway, so it's going to be 10 plus whatever this integral is. So that's integral from 0 to 1, 3t squared minus 8t plus 1 dt. We don't have a calculator, so we need to do an antiderivative for this. That's going to be t cubed minus 4t squared plus t, but of course we're going to evaluate this from 0 to 1. Okay, so 10 plus, if I plug 1 into this whole expression, that's going to be 1 minus 4, which is negative 3, plus 1, which is negative 2. And then technically I'm supposed to subtract this whole expression evaluated at 0, but that expression evaluated at 0 is just 0. So I think it's 10 plus negative 2, which is negative 8. Number 88, if f of 9 equals 6 and f prime of 9 is equal to negative 2, the best estimate for f of 7 would be, this is a linear approximation problem. Basically, you can write down the equation of the tangent line and then plug 7 into it. So I'm going to write down the equation of the tangent line at x equals 9. So that would be y minus y1 equals m times x minus x1. What's the point on the line? Well, it's going to be 9 comma, what is f of 9? Well, you're told what it is. It's 6. And then what is the slope m? Well, of course, that's f prime of 9, like the derivative at 9. But you're told what that is. It's negative 2. So that's negative 2. So the equation of the tangent line at 9 would be y minus 6 equals negative 2 times x minus 9. Now, if you want to use this to approximate f of 7, you should just plug 7 into that equation for x. So you get this, solve for y, that'll be your answer. Number 89, this is going to look like a mysterious question. It has to do with using the chain rule in Leibniz notation. I don't really talk about this much in my class. Usually I'll make a comment about it at the end of the year. I'll explain it now. Numbers 89 and 90 are both about this. Basically, of course, in regular notation, so let me say 89 and 90. This is sort of an explanation for both of these problems. In prime notation, the chain rule says this. You have f of g of x, so you have a composition, and you want to take the derivative. What is that? Well, it's f prime of g of x times g prime of x. That's how you'd write the chain rule using prime notation. How do you write this using Leibniz notation? It's this. It's dy dx equals dy du times du dx. What in the world is going on there? Like, how is this the same as this? I'll explain why. I'll just point out that there is one nice thing about using Leibniz notation to express the chain rule, because it has some kind of logic. If you pretend that these things are literally fractions, which they're not, but if you pretend that they are fractions, then it looks like you're just canceling the du's and getting dy dx, so it kind of makes sense. But let me show you how to use the Leibniz notation for the chain rule here. So you're told that y is equal to u squared and that u is equal to sine x. just really quickly, you could do this by just saying, oh, sorry, u is equal to sine x, right? Really quickly, you could do this very easily by just saying, oh, well, if y is u squared and u is sine x, that just means that y is equal to sine x squared. And you can find dy dx in the usual way, right? Chain rule, it's going to be 2 sine x cosine x, voila, which is this guy right here. But, using the Leibniz notation method of doing the chain rule, which I don't like, I don't love it, I don't usually teach it this way, here's what you would say. You would say, well, look at this formula. You want to find dy dx, right? You want to find the derivative of y with respect to x. So first you compute dy du. That would be, so dy du, that's like saying take the derivative of y with the assumption that u is the variable. That would be 2u. Then you got to compute du dx. That's saying take the derivative of u with the assumption that x is the variable. So that would be du dx is equal to cosine x. And so dy dx is going to be dy du, which is 2u, times du dx cosine x. All right, so you would say dy dx equals, you would say dy dx equals 2u times cosine x. But then you remember what u is. U is sine x. That's 2 sine x cosine x. And you get the same answer, but, I hate this way of explaining the chain rule. I think it's just really notationally confusing. So I don't like teaching it this way, but there it is. As far as number 90, like, if you know this, number 90 is trivial. Like, look at this equation and look at what they tell you. dy du is 10, all right? Replace this with 10. Du dx is 5, all right? Replace this with 5. What's dy dx? It's 10 times 5, which is 50. The end. Anyway, number 91. What is that antiderivative? Yeah, this is a bit tricky. We haven't really talked about antiderivatives involving compositions. I think they basically expect you to guess. All right, like I would guess something like 2 sine 2x. Like, the 2, I think you should just copy, and antiderivative of cosine is sine. So maybe the antiderivative of cosine 2x is just sine 2x. But if you check this guess by taking the derivative, you'll see that it's wrong, right? Like if you take the derivative of this, because of the chain rule, I mean, you're going to get 1, 2 because of this 2 right here. But then when you take the derivative of this guy, the chain rule is going to tell you cosine 2x times 2, and you actually have an additional factor of 2 here that you didn't really want. So what you can do is you can say, okay, so that's wrong. I'm going to make a different guess. I sort of wound up with another factor of 2 that I didn't really want. So maybe actually I just shouldn't have that first 2 to begin with, and just do that. And if you check, the derivative of this function is indeed just this. So this is the antiderivative, plus c. So it's basically just kind of guessing and checking. Number 92. Which of the following is the equation of the tangent line at x equals 1 for this function? Well, anytime you want the equation of the tangent line, you just want to do y minus y1 equals m times x minus x1. So we need two things. We need a point on the line, and we need the slope of the line. The point on the line, well, the x value is 1. To find the y value, you need to plug 1 into the original function. So if I plug 1 into this, what am I going to get? 2 times 1 minus 1, which is 1, to the 5th is still 1, times 1 plus 1, which is 2. I think it's just 2, right? And then what's the slope? Well, for the slope, I need to find the derivative and plug 1 into that guy. So I think I need to find the derivative of this function, which is not so easy. It's like product rule and chain rule. So product rule, there's two factors. One of them is 2x minus 1 to the fifth, and the other one is the x minus 1. So I'm going to do the product rule first. So take the derivative of that first factor. You get 5 times 2x minus 1 to the fourth times 2 because of the chain rule, right? That first factor is a composition. So that's the derivative of the first factor times the second factor left alone. Plus, now I leave the first factor alone, 2x minus 1 to the fifth, and I take the derivative of the second factor, but the derivative of the second factor, derivative of x plus 1 is just 1, so times 1. Okay, so there's the derivative. Now I need to plug 1 into this. If I plug 1 into this, 2 times 1 minus 1 is just 1, so it's 1 to the fourth. So, like, all these factors of 2x minus 1 are just going to be 1. So it's 5 times 1 times, this is 2, and then if I plug in 1 for x, I think this is another 2. So I get like 2 factors of 2. Plus plug 1 into this guy, that's just 1 times 1 is 1. I hope I'm doing this right. So this is 5 times 4, I think that's 21. So I think the slope is 21, and that is one of the options. So okay, so that's looking pretty good. So I think the equation of the tangent line would be y minus y1, that's 2, equals m, which is 21, times x minus 1. Of course, their equations are all written in like y equals mx plus b form, like they solved for y. So let me solve my equation for y. That's 21x minus 21. I'll add 2 to both sides. I have y is equal to 21x minus 19. Okay, that is one of the options, so probably right. Number 93. This is an implicit differentiation problem. There was already one of these earlier in the packet. The only difference is now it's w's and s's. This notation here means that w is the function and s is the variable. So basically, s is a function. Sorry, w is a function, s is a variable. So I take the derivative of both sides, keeping in mind s is a variable, w is a function. So derivative of s cubed, that's just 3s squared, because s is a variable. Plus, for this guy, the SW, I need the product rule. So differentiate the first term. Derivative of s is just 1 times w left alone. Plus, leave the s alone. Derivative of w is a function, so that would be w prime. Equals, all right, derivative of the right-hand side. Since w is a function, w squared is a composition. You get 2w prime. Now I got to solve for w prime. So I got to put all the terms involving w prime on one side, all the terms that don't involve w prime on the other. So maybe that's, one way of doing it is sw prime minus 2w prime equals negative 3s squared minus 1w, or just minus w. Factor out w prime, quantity s minus 2w equals negative 3s squared minus w. Divide w prime is equal to negative 3s squared minus w over s minus 2w. I got a feeling that's not going to appear among the answers because there's an easier way of writing it. Like, if I change the order of the subtraction here, that's like this. Like, I can write 2w minus s, but that produces a minus sign. Like, when you switch the order of subtraction, you get a minus sign. And that minus sign will actually, just kill the minus signs in the numerator. So 2w minus s, 3s squared plus w. So I would expect that to be one of the answers. Yeah, it looks like it is. This weird simplification with the minus sign stuff, doesn't happen if you choose to move your primed terms over to the right instead of the left like I did, but whatever. 94. Find the derivative of this guy at 3. This would be another product and composition. it's 5x times root x squared plus 1, so that's product. But when we take the derivative of the root x squared plus 1 term, we're going to need the chain rule. So y prime is derivative of 5x is 5, leave the root expression alone, plus leave the 5x alone, and now take the derivative of the root expression. What's the derivative of the root expression? It's 1/2 x squared plus 1 to the negative 1/2, and then times the derivative of the inside function, which is 2x. So this needs to be simplified. So 5 root x squared plus 1 plus, let me see what's going on here. This 1/2 here will just cancel with that 2 over there. I'm going to have a denominator because of this negative exponent. Let me create one. So I've got x squared plus 1 to the positive 1/2, oops, in the denominator. And then in the numerator, the 2's, as I said, have canceled, but I do still have a 5, and I think I've got 2 copies of x, so I think it's 5x squared, so that looks like the derivative. Now I just need to plug in 3. So y prime evaluated at 3 is going to be 5 root 3 squared plus 1 is 10, so root 10 plus 5 times 3 squared is 5 times 9 is 45 over, what is this denominator? It's root 10, isn't it? 3 squared plus 1 is, yeah. Okay, is that any of the options? Yeah, it is. It's this one, right? 45 over root 10 plus 5 root 10. That's what I have, just in reverse order. So, okay, that's looking pretty good. Number 95. Okay, obviously the table is like kind of screwed up here and split over 2 pages, but that's okay. The table to the right gives values of functions f and g and their derivatives at 3. God, what is going on with the formatting? Okay, if h of x equals f over g, then what is the value of h prime of 3? Well, you're just supposed to say if h of x is equal to f of x over g of x, then h prime of x can be found by doing the quotient rule. So that's f prime of x, g of x, minus f of x, g prime of x, all over g squared of x, whatever. So it's like g of x all squared. So h prime of 3 is obtained by just plugging 3 into all of these things. So it's f prime of 3, right, which is 5. So that's going to be 5 times g of 3, which is 2, minus f of 3, which is negative 1, times g prime of 3, which is negative 2, all over g of 3 squared. So that would be 2 squared. So simplify this and you'll have your answer. Number 96. Let f of x be a differentiable function such that f of 0 is equal to negative 5 and f prime is less than or equal to 3 for all x of the following, which is not a possible value for f of 2. This is kind of a hard problem. Basically, if you think about it, what they're telling you here is that f of 0 is negative 5, and the rate of change of the function is always less than or equal to negative 3. What that's doing is it's kind of putting an upper bound on how much the function could increase between 0 and 2. Like, since the rate of change is always less than or equal to 3, the most that the function could increase would happen if f prime were just equal to 3 the entire time, right? Like, if f prime were just equal to 3 the entire time, how much would it increase by? It's increasing by, it's got a slope of 3, so from 0 to 2, it would increase by 6, and the value of the function would be negative 5 plus 6. So 6 is the most the function could possibly increase by. And so that means that, the biggest that f of 1 could possibly be would be negative 5 plus 6, which is 1, right? So that's the biggest that this function could possibly be. So 2, there's no way it could be 2. Okay, there's no way that it could be 2. Because 2 is bigger than 1. 97, consider the function blah blah blah, for which of the following values of x is f not continuous. That's just going to be anywhere this thing isn't defined. So that's at 2, and that's at negative 1. There's nothing wrong with negative 3. That's just where the function's equal to 0. Yeah. And maybe you think you can cancel the 2's or something, so the 2 doesn't matter. No. The original function's not defined at 2. It has a hole at 2. Anyway, 98, you got this function. Where is it decreasing? That just means where is the derivative negative? So take the derivative, do a sign analysis. That looks like x squared plus 3x minus 70. Okay. So I guess I need to factor this. Like set it equal to 0 and solve. Pair numbers that multiply to negative 70 and add up to 3. I guess 10 and negative 7, right? I think that works, right? Yeah. Okay, so you get x is equal to negative 10 and positive 7. So my number line looks like this. I got negative 10, and then I've got 7. If I plug in like a really big positive number, then it's going to be positive. This is going to be negative. That's going to be positive. So where is the function decreasing? Well, that's where the derivative is negative, and that's between negative 10 and 7. Number 99. Which of the following is an equation of the line tangent to the graph of this thing at 1, negative 3? Well, anytime you want to write down the equation of the tangent line, you need to do point slope form, which is this guy. So of course you need two things. You need a point on the line, which they give to you. It's just 1, negative 3, and you need the slope of the line, m. Well, that's harder, right? You need to find a formula for y prime first, and then see what the slope is at this point. Of course, this is not a regular function. This is a function which is defined implicitly. It's like an implicit equation with the x's and y's mixed up. So to get a formula for y prime, you have to use implicit differentiation. So take the derivative of both sides, being careful to remember that y is a function of x. So 2x minus, well, now we got to be careful. This is the product rule here, right? Like I would say the first function is negative 3x, and the second function is y in the product. So derivative of the first function, so derivative of negative 3x is just negative 3. Leave the y alone. Plus, now leave the first function alone. So that's negative 3x, and take the derivative of the second function, which is y prime, equals derivative of the right-hand side is just 0. Now you got to solve for y prime. So move all the terms not involving y prime to the other side. That would be 3y minus 2x. And then divide both sides by the negative 3x. And so I want to know what's the slope here. So that just means plug in 1 for x and plug in negative 3 for y and this formula. So 3 times negative 3 minus 2 times 1 over negative 3 times 1. So negative 9 minus 2 is negative 11 over negative 3, so that's 11 thirds. So the slope is 11 thirds. I hope that's one of the options, or I screwed up somewhere. Ruh-roh. Oh, there it is. I guess I can kind of stop there. I know that this has to be it because that's the only one with a slope of 11 thirds, but I'll finish it. So y minus y1, so that's y plus 3 equals m, which is 11 thirds, times x minus x1, which we said is 1. So that would be, yeah, so that's E right there. cool. Number 100. What is the antiderivative of this function? Sorry, it's not just the antiderivative because it's a definite integral, right? So we're going to find the antiderivative and then plug in 9, plug in 1, and subtract. So you're looking at the antiderivative of x to the negative 1/2. What's the antiderivative of x to the negative 1/2? I think it's going to be 2x to the positive 1/2, right? Always double check. If I take the derivative of this, do I get x to the negative 1/2? Yeah, I do. Okay, so that's the right one. So I'm just going to write evaluated, because I don't have a vertical bar notation like on my keyboard. It's hard for me to write that, so I'm just writing evaluated 1 to 9. So plug in 9, plug in 1, subtract. So 2 times 9 to the 1/2 minus 2 times 1 to the 1/2, and whatever that is, that should be the answer. So that's 2 times 3 minus 2 times 1. So that's 6 minus 2, which is 4. Okay, cool. 101, what's the average value of the function shown here? Well, you know, the average value is, of course, 1 over b minus a times the integral from a to b f of x dx. This guy here, that part of the expression, that's the area under the curve, which, you know, we can find because this is obviously just a semicircle. So what is the area under the curve? Well, it's half of a circle, right? It's like going to be 1/2 of pi r squared. R, of course, in this case is 4, so that's 1/2 pi times 4 squared. So that's 1/2 times 16 pi. So that's 8 pi. So the area is 8 pi, which means the average value is 1 over b minus a. So that's 1 over 4 minus negative 4 times 8 pi, which is just pi. Yeah, so I just get pi there. So that would be D. Oh, and we're done. Thank God. Okay, guys.